All right, so getting ready 34, our first problem here says the theater wants to take in at least $2,000. So that means greater than or equal to 2,000 for a certain matinee. Children's tickets, $5 each. Adult tickets, $10 each. Okay, so part A, write an inequality describing the number of tickets that will allow the theater to meet their goal of 2,000. Well, that says very vaguely just number of tickets, but there are two kinds of tickets. There are adults and there are kids. Okay, so we need to account for both of those. So that's where our let statements come in. So it doesn't matter which one you call X and which one you call Y, but you do need two variables. So I'm going to call X my child tickets, and I'll let Y equal my adult tickets. Okay. So I want an inequality describing the number of tickets, so kids in X and Y, that will allow the theater to meet their goal of $2,000, which is at least $2,000. I'm not writing an inequality about number of tickets yet, just about the money. So if a child ticket costs $5 and I sell X of them, that's 5X. I add on the money I make from adult tickets, which is $10 each. I sell Y of those, and I want greater than or equal to 2,000. Now, part B is where the other inequality, the one regarding number of tickets, comes into play. This time, if they have a maximum of 350 seats, that means they've got to keep it less than or equal to 350, the number of seats they can sell. Let's write an inequality representing both types of tickets. So for part B, I'm going to write the number of child tickets plus the number of adult tickets total, when I put them together, has to stay less than or equal to 350. And then the last question on the front here, question C, is find the number of child tickets and adult tickets that can be sold so that all seats are sold and exactly 2,000 is made. So that means we want to take the inequality parts out of this and just consider them both equations. So for the sake of space, I'm going to move up here and say my inequality regarding the profit, the money I wanted to make, 5X plus 10Y, I'm going to change it to just equals. We want it to be exactly 2,000. And if all seats are sold, that means every one of the 350, so that one turns into X plus Y equals 350. Now, it does not tell us a method we should use to solve this. I would certainly think that substitution would be okay because this X and this Y are both virtually alone as they are now. I'm going to use substitution because I tend to pick that whenever both equations are in standard form. So if I multiply this second equation by -5, it becomes -5X minus 5Y is equal to -1750. If I add the first and third equations here now, 5X plus -5X is eliminated. 10Y minus 5Y is 5Y equals 2,000 and -1750 is 250. Divide both sides by 5. So Y is equal to 50. That means since Y was adult tickets, 50 adults. Now, how many kids? Well, I need to substitute that 50 back into either one of the equations. It's certainly a lot easier to put it into the X plus Y equals 350 equation. So if I put 50 for Y, X plus 50 is 350, meaning the X has to definitely be exactly 300. Okay, so 300 child tickets. Okay, number 2, now we're going to look at graphs, and we're going to write the inequality or set of inequalities that match the graph. All right, now in number 2, there is only one line and one color, one region that is shaded. So that means we're only going to write one inequality, not a system. Okay, so if you recall, to start making the inequalities, we need to identify 2 points off that graph so we can make the equation of the line itself. Well, I see one here is -8, 0. I can see the y-intercept is 0, -4. So to get my slope, my rise over run, I can count down 1, 2, 3, 4. So rise -4, run 1, 2, 3, 4, 5, 6, 7, 8. So down 4, right 8 is a slope of -1/2. Since I can already see the y-intercept is 0, -4, I know the equation of that line is y equals -1/2 x minus 4. But we're not trying to just write the equation of the line. We need the inequality for this graph. Well, it's shaded above the line, so y is greater than -1/2 x minus 4. And then our last decision is, do we include the equal to bar under the greater than sign? Since this is a dashed or a dotted line, it's not a solid line, we do not. We want y just to be greater than -1/2 x minus 4. Okay, number 3, we are seeing, it's actually 3 different colors, but 2 lines, 3 different colored regions shaded. So one of them would be shaded in blue and one shaded in pink, and then the blue and the pink overlap and make purple. Okay, so let's do these one at a time. If I start with the shading in blue, well, that came from this line. So I need 2 points off of that line. The x-intercept here is -2, you can't see that, -2, 0, and the y-intercept is 0, 8. So what is my slope? What is my rise over run that resulted in this dotted line? Rise over run, it went up 8 and right 2. So up 8 and right 2. 8 over 2 is 4. The y-intercept is 8, so the equation for this line is y equals 4x plus 8. Now let's put it in the terms of an inequality. That's y, since the blue shading is under this dotted line, it's less than 4x plus 8. And because it is a dashed line, we do not want to include the equal bar under the inequality symbol. Now, for the line that resulted in the pink shading, that's this line. Again, we need 2 points. So I can see here that the y-intercept is 0, 4, and the x-intercept is -8, 0. So the rise over run for that line, it rises 1, 2, 3, 4, and then runs 1, 2, 3, 4, 5, 6, 7, 8. So 4 over 8 gives me a slope of 1/2. Again, the y-intercept is 4, so that is y equals 1/2 x plus 4. So again, the pink shading is underneath the pink line, so y is less than 1/2 x plus 4. And we have to ask, do we want the equal bar? Well, since that's another dashed or dotted line, no. So this is our system of 2 inequalities that results in that graph. All right, and this time we're going to have this line results in the blue shading, and this line results in the pink shading. Because everything below this line is pink, everything above this line is blue, and when they overlap, we get purple. Okay. So let's look for some points. So on this line that we're calling the blue line, I can see that the x-intercept, no, I can't tell the x-intercept. The y-intercept is 0, 1. And then I can see another point here is 2, 4. So my rise over run then, it goes up 1, 2, 3, and runs 2. So the rise over run, up 3, right 2. The y-intercept is 1. So again, that equation would be y equals 3/2 x plus 1. Well, it's not just an equation we're looking for. We're looking for the inequality. So for that line that we're thinking of as the blue line, y is, since the shading is above this blue line, y is greater than, since it is a solid line, greater than or equal to 3/2 x plus 1. All right, for the other line, the one I'm thinking of as a pink line, I can see that the y-intercept is 0, 10, and I can see it also contains the point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 5, 8. So the rise over run on this one, it would go down 1, 2, and right 1, 2, 3, 4, 5. So down 2, right 5. With a y-intercept of 10, that means y equals negative 2/5 x plus 10. Now let's come up with the associated inequality. That would be y is, because the shading is beneath that line, less than, because it's a solid line, equal to, and then negative 2/5 x plus 10. And there is our system of two inequalities. Okay. Number 5, we now are going to graph these on our own. So we need to make sure we're including the shaded region of each, plus then the region where they overlap, that works for both. So I like to color code these so that I know which ones I'm graphing. So I'm going to call this first inequality the red one. So x minus y is less than negative 6. Now, we can solve for y, and then if we keep track of our inequality symbol while we do that, we don't have to do any test point. We can just trust the inequality symbol. That is dangerous, though, because when you have a negative sign in front of this y, we often forget to flip the symbol when we cancel it. Watch this. Subtract x on both sides, so I'm left with negative y. It's still less than negative 1x minus 6. But I need to get rid of this negative sign in front of the y by dividing by negative 1 on every single term. And when you divide an inequality by a negative, the inequality symbol switches. So it goes from a less than to greater than. Now here's negative 1x divided by negative 1 is 1x, and there's plus 6. Now, if you can keep track of those signs, then most of your work is done here. We're ready to jump right onto the graph and say our y-intercept is 6, and it has a slope of 1, meaning rise 1, run 1, up 1, right 1, up 1, right 1. And since it is just greater than, not greater than or equal to. We want a dotted or dashed line. Oops, that should be red, not blue. Let's make that red. Everything above the red line is shaded. For the blue one, 2y is greater than or equal to 3x plus 16. We only have one step in order to solve for y, and that's to divide everything, all terms, by 2. So we end up with y greater than or equal. We do not have to switch the symbol. 3 over 2 is 3 halves, x. 16 over 2 is 8. So our y-intercept is 8, and our slope is 3 over 2. So that would mean from this y-intercept of 8, we rise 1, 2, 3, run 2. Rise 3, run 2. And that one is not a dotted line. This one is a solid line because it is a greater than or equal to. Now this one, we would shade everything above because it's greater than or equal to. So everything above the blue line shades this. So we have one pink section, one blue section. Now, where did they overlap? So the region that is true for all inequalities would be the parts that I shaded both blue and pink. So that would be above both lines. So this region where I overlapped blue and pink is the solution for both inequalities. We should indicate a little better where that pink one, there. Okay. I'm going to go through all those steps again. We have another system of inequalities. I'll make a red one and a blue one. My red one, 5x minus y greater than or equal to 5. As I am solving for y, I will subtract 5x on both sides. That would leave me negative y greater than or equal to negative 5x plus 5. To eliminate this negative sign, divide every term by negative 1. I do need to remember, though, since I'm dividing by a negative, to change that inequality symbol. So this becomes y is less than or equal to positive 5x minus 5. So our y-intercept is negative 5. Our slope is 5, or 5 over 1, so we will rise 5 and run 1. Rise 5, run 1. 5, 1, 5, 1. This line will be solid because it's less than or equal to. So a solid line. And we will shade everything below that line because it's less than or equal to. So everything below this line means everything here. Our blue one. 2y is, or 2y minus x is greater than or equal to negative 10. To solve for y, I will first add x to both sides, giving me 2y greater than or equal to x minus 10. Then I will divide all terms on both sides by 2, which leaves me y, symbol doesn't change, greater than or equal to. Now this is 1x divided by 2. That coefficient of 1 over 2 is 1/2 x. and minus 5. So here's another one with a y-intercept negative 5. This time your slope is 1/2. So rise 1, run 2. Rise 1, run 2. 1, 2. And again, it's a solid line because it's greater than or equal to so a solid line and we will shade everything above since it is greater than. So in blue, we would shade everything above this line. So all of this should be blue. So where did we shade twice? Where did we overlap? Which will result in my overall solution. It's this region above both lines. So all of this is my official solution to the system. All right, now we're back to just equations. We're going to solve these systems of equations, and that means by whatever method we choose. So we could do graphing. We know how unreliable it is or how it requires you to use your graphing calculator. So really, I'm hoping you're using either substitution or elimination. For number 7, since both of them are in standard form, I choose to use elimination. When I look at the x's, the coefficients 3 and 5, I cannot change just one of those and get opposites. I would have to change both. So if I look at the y's, they can be done a little simpler. If I just multiply the second equation by negative 5, because I need to change one of these into a positive. So if I multiply by negative 5, this becomes a positive 10. So we would have negative 15x plus 10y equals negative 15. Add the top and the bottom. So 5x and negative 15x is negative 10x. Negative 10y plus 10y is eliminated. And then 15 and negative 15 is 0. Divide both sides by negative 10. X is equal to 0. So that's half of my solution. I need to plug that 0 back into any one of the problems. So I'm going to use this one. 3x minus 2y equals 3. Putting 0 for x, that's 3 times 0 minus 2y equals 3. 3 times 0 is 0. Don't need a 0, so I can just ignore that and say I am going to divide both sides by, by negative 2. And y is negative 3/2 or negative 1.5. So my solution is the point 0, negative 3/2. Number 8. This one is also in standard form, both equations. So again, I would choose to use elimination. Same thing with the 3 and the 5. I would have to change both in order to eliminate those. So I'm going to choose to eliminate the y values by just multiplying the top one by negative 2. Negative 2 times that negative 1y will give me positive 2y. All right, so here we go. Negative 2 times 5x is negative 10x. Negative 2 times negative y is positive 2y. Negative 2 times 10 is negative 20. Adding the second and third equations, 3x and negative 10x makes negative 7x. The 2y and negative 2y are eliminated. Negative 1 and negative 20, negative 21. Divide both sides by negative 7. X will be 3. Substitute that 3 back into any of the equations above. I'll use this top one. 5 times 3 minus y equals 10. 5 times 3 is 15 minus y is 10. Subtract 15 on both sides. So negative y equals negative 5. Divide both sides by negative 1. Y is equal to 5. So that solution, 3, 5. And number 9. We have another set that are in standard form. So if I were actually doing this for myself, I would use elimination again. But just to show that we can do it, I'm going to go ahead and do this one by substitution. Okay. So none of these 4 variables, neither x or neither y, look like they would be real simple to isolate. So I'm just going to make a random choice and say I'll choose this x in the top equation. So 5x plus 7y equals 15. I am going to solve that for x. So my first step would be to subtract 7y. So I would have 5x equal to 15 minus 7y. And then I would divide everything by 5 so that this is x equal to 3 minus 7/5 y. And that is what I put in the box. All right, I do that so I can substitute this box, everything in the box, for x in the other equation. So 7 times everything in the box, 3 minus 7/5 y, minus 3y is equal to 5. So start with distributing 7. 7 times 3 is 21. 7 times negative 7/5. Well, remember that's 7 over 1. So a positive times a negative is negative. 7 times 7 is 49. 1 times 5 is 5. Y. And then minus 3y equals 5. Well, I have some like terms here to combine. So let me go over here on the side for a minute. Negative 49/5 minus 3. Well, remember, this is 3 over 1, and we need to make common denominators. Common denominator for 1 and 5 would be 5. So this can stay negative 49/5 minus, now since I multiplied this 1 by 5 to change the denominator, I do the same to the numerator. That's 15/5. So negative 49 minus 15 is negative 64/5. Now, it is okay, that is a terminating decimal, so if you would rather change that into negative 12.8, you're welcome to use that. I'm going to keep the fraction just to show it that we can. So here we have 21 minus 64/5 y equal to 5. We will subtract 21 from both sides. So I have negative 64/5 y equal to negative 16. Now, since this has a fractional coefficient, the simplest way to get rid of that is to multiply both sides by the reciprocal. The reciprocal of negative 64 over 5 is negative 5 over 64. So these cancel. That was the reason we did it. We have y equal to, now negative times negative is going to be a positive answer. 16 is over, the negative 16 is over 1. 16 times 5 is 80. 1 times 64 is 64. Now to simplify that, both of those can be divided by 16, so that is 5/4 or 1 1/4. Okay, either of these answers are great.